Obviously, I'm not Lauren Perry, so I apologize she was not able to make it today, but I assure you that we worked very closely together on a lot of the topics here, and I'll do my best to represent our combined work. So at the Aerospace Corporation, I've been spending the last 10 years or so working primarily in machine learning model development, and lately I've been translating that into kind of guidance and discussions with our customers across different government agencies and commercial agencies as well, to provide some recommendations for best practices going forward as they try to deploy machine learning algorithms, in particular in relation to concepts like mission assurance, which is something that Aerospace has been providing to a number of our customers over the years. So just to motivate this discussion a little bit, obviously we all know that AI has proven to be highly successful in a number of different applications, and this has led to an increasing role of AI in automated decision making and allowed AI to become more pervasive in a number of different domains. But that also has consequences. Because of this increasing presence of AI, there's also been increasing scrutiny on the risk of impact to stakeholders within organizations, and also increased awareness of responsibilities for those organizations. And in response to those concerns, there have also been a growing number of regulations, many of them across different nations across the world, as this somewhat outdated chart tries to demonstrate. But as many of you are probably aware, even within the DoD and IC, there are things coming out such as the AI ethical principles from the DoD, the foundational tenets, and work from the JAIC on how to do T&E for robust AI systems. So clearly it's becoming apparent that ethical and trust considerations can no longer really be an afterthought. They're more of a requirement and should be part of the machine learning development lifecycle. Now, there have been a number of industry-specific regulations, which I mentioned briefly here, that try to provide very targeted guidance about how to develop and deploy machine or any type of algorithm. But the policies and best practices that are available now are somewhat operating at a higher level. So our hope was to provide some best practices more on the implementation side about how one would actually try to adhere to these new regulations and policies that are coming out. So for a little bit of background, about 3 years ago or so, the Aerospace Corporation decided to have an initiative to put some time and energy in understanding trustworthy AI. And the result of that, after doing a market survey, literature review, and combining and generalizing a lot of the topics we were seeing, was what we call the Aerospace's Trusted AI Framework, targeted towards our specific customer base. And along with the different concepts within that framework, which we tried to map to the machine learning development lifecycle, are a number of definitions. And just so that we're all on the same page, when I say trusted AI, I'm referring to an AI capability that provides sufficient confidence of satisfying user-defined objectives in a proper, interpretable, and safe way over its lifetime. And the different threads, which we break out within the lifecycle or in the framework, are meant to address different parts of that lifecycle and the pieces that will be required to address to satisfy different needs and risks during different phases of development. Now, one of the critiques that we got from socializing this framework was that it was too conceptual. And in response to that, we had put forth a number of different use cases to illustrate how it could be applied in practice, which also led to a number of collaborations with other organizations. A particular note would be a collaboration we've been doing with JPL for the past 2 years, where we apply the framework to specific ongoing projects and show how trusted AI considerations impact the development of requirements and how that may change the role of different stages of algorithm development and testing. And if interested, I can provide references to two IEEE papers which will be coming out shortly that just discuss those use cases and their application. Now, while we applied the framework to the use cases, then that certainly did help understand how trusted AI could be implemented in practice. We did start to notice some general themes in the implementation side as well. And we noticed that some of those themes come up in also an emerging practice of MLOps. Now, MLOps additionally has been having a number of years of development and has been reaching a higher level of maturity as of late. But the motivations are a little bit different than those that are tied to like ethical AI. Now, usually when we're talking about MLOps, we're more concerned about realizing the potential value of an AI system when it's deployed and addressing the problems that are often observed where, if a business decides to develop a machine learning algorithm, in the research and development phase, the performance looks to be a certain quality, but when deployed, that performance diminishes or is not as expected. So the point of MLOps is to manage that transition from development to deployment and reduce the risks that might be imposed from a poorly operating model. Now, as you can see, this also follows the machine learning lifecycle and maps to different phases within. But there's particular emphasis on the different phases of model development and how one would address machine learning considerations, but also increased emphasis on pre-production and production phases as well, and how to manage that gap successfully. Now, I'm talking about a number of different frameworks and processes, and obviously with those come a significant amount of effort. And I want to make it clear that not every AI algorithm deserves the full gamut of testing and best practices. And really you need to scale the amount of trust and MLOps investment to the needs of that particular application. So there are many ways one can think about this measurement of trust required. One of the ways that we found resonated with some of our customers was to break it out according to algorithm criticality, complexity, and level of autonomy. So by criticality, what I mean is the relative impact of the algorithm on the mission success of whatever capability you are developing. By algorithm complexity, typically we're talking about the ability to understand the processes that led to a particular prediction. And of course, level of autonomy has a direct impact on one's ability to control or intervene once an algorithm has been deployed. Now, of course, when talking about assessing the degree of trust, this is something that needs to be developed in close concert with the stakeholders that would have to be responsible for the AI algorithm, including defining what success looks like and estimating the level of effort required to match the budget that is available for the development of the algorithm. And hopefully, by also looking at the best practices recommended through MLOps, one can also kind of manage the operational risks that might be associated with deployment as well. Now, one last preliminary point that I'll make here is that we're talking about developing algorithms, but it's not just a technology. People need to actually do the work of development and putting in the hooks for being able to measure the trustworthiness of an algorithm. So cultural elements are very much at play here. When collecting a team of developers, that should be a multidisciplinary team that understands the risks of AI development, but also the risks to the organization if something were to go wrong when deployed. Typically, there'll be subject matter experts that understand what the possible business use case will be, and they should have definitely a strong say in how MLOps is employed, because they will need to be able to audit the system, and having metrics and monitoring mechanisms will be crucial for them to understand whether or not the business objective is being met by the AI algorithm when deployed. So this needs to be a collaborative development where we are very upfront about the fact that developing trust will be somewhat of a journey through the machine learning model development. And really we're striving for informing all the different stakeholders. We don't intend to say that we're going to solve trustworthy AI with these processes, but at least we can say that there is a process in place to address the known risks and that there is someone responsible for understanding what those different processes are. So if an audit were to occur, for example, someone can be asked to discuss the practices they put in place to manage risks. So now what I'll do is I'll step through the different phases of the machine learning model lifecycle and point out some of the different aspects of it which are relevant to not only machine learning and trustworthiness, but also how one might align that with the different parts of the MLOps best practices as well. So the first phase, which we often refer to as like thread zero or step zero, is the value proposition. And unfortunately, there are many cases where AI is implemented for the sake of AI, and we certainly recognize there is a need for research to understand whether or not there is some feasible path forward for using AI. But when it really comes time for deploying some new system or capability, one needs to show that there is a need for an AI-based capability. Simpler approaches might meet the needs of whatever your key performance parameter might be. And there should also be some literature review to understand whether or not there are any known risks or limitations to a particular algorithm, including things like the amount of data required, all the way to the potential performance of that algorithm. So when developing a value proposition, one needs to be sure to identify the stakeholders that will have to be convinced of its potential benefit, tailor the language to their needs, and incorporate their perspectives in the development plan. Those metrics of success should be in the target domain, and I'll discuss that more later. But really what we're talking about here is, once again, acknowledging the risks that are likely to impact the successful deployment, and try to minimize any risks as possible in the early stages. Choose a less complex model if it's going to meet your objectives. Isolate its function as much as possible, and leverage whatever other systems and code bases might be available. Now, as we move on to the initial stage of development, one of the things that we think is crucial is the task specification or objective specification. And here we mean a clear description of the AI objective, along with the metrics that would demonstrate its alignment to your business objective or your task. And it might seem like a trivial component, but quite often what happens is that there is a difficulty in translating an objective that you and I can clearly describe in plain English into something that can be optimized by an AI algorithm. And something that is based on the behavior of a person can be very hard to specify in terms of some kind of a mathematical function. So if possible, one can deal with this through breaking down the algorithm into modular components, which are as simple as possible and would also make test and evaluation more tractable. And of course, defining requirements from each of those, which could then be rolled up into a higher level understanding of a more complex behavior. And additionally, also making sure that these metrics will be available for inspection from the people that would need to audit the algorithm, for example. And also making sure that the metrics that are used to develop the algorithm, the optimization loss function, for example, can be related back to the business objective. Now, of course, at this point, one would also want to understand the potential risks identify the failure modes and what could lead to them, in particular, how the AI could lead to those, identify any security or adversarial risks, and an understanding of what the potential impact of the organization could be if something were to go wrong. Now, there's a lot here on the data specification slide, but this phase is particularly important in any kind of machine learning algorithm, as the behavior is defined by the data you use to train it. And additionally, how one understands the data that was used to develop the algorithm will inform many of the later stages of development in terms of assessment and providing the monitoring capability that would be used all the way through deployment. So, there's been a lot of great discussion in the past couple of years about understanding not only the traceability of the model development, but also the traceability of the data set creation and storage and preparation for machine learning development. So capturing details of how data was collected, what the pre-processing steps were used to get to a stage of model training, all very important parts that should live alongside the model and be captured just as faithfully as the actual model development itself. Now, there are additional things that are recommended, such as the exploratory data analysis phase, which is crucial to understand what is nominal and what is out of scope for the data that you're planning to use, identifying potential subgroups and the relative representation, which will have an impact on things like fairness and bias at later stages of development, and also looking for challenging data examples that may be experienced in deployment and how to mitigate those. Now, alongside that, this might be another opportunity to consider additional checks, such as checking for out of distribution or out of scope data, and maybe have that upstream within your larger system that is using the AI capability. And that, again, that might come in handy later when monitoring is a more crucial component to the ML lifecycle. Okay, so as we move on to thread 2, the purpose of the next couple of slides is to show a number of different attributes that would be relevant during the development phase and which might allow one to develop metrics that would be used to assess the quality or trustworthiness of an algorithm. These will not be comprehensive, but we feel like they are at least a baseline that could then be leveraged for development and maybe enhanced for specific use cases. So there are going to be some I don't talk about today, like security, or privacy, which might be very crucial for some applications, but not others. So the first one I have here is traceability. I did reference that a little bit already, but the idea here is to document and maintain all the artifacts related to the implementation and evaluation of the AI system. So not only should one have a record of all the different data preparation steps, along with version control of not only the code, but also the model and data, but also have a good sense of performance metrics along the way, and maybe also an idea of how those led to design decisions as the development phase matured. Many of the stakeholders will have to be involved in this phase, as they will all have input not only in what is recorded and what is relevant to the machine learning success, but again, when it comes time to audit and understand the performance of this model in practice or in deployment, subject matter experts and auditors will need to understand what are the relevant pieces they'll need to keep track of during deployment. Stability is another attribute which we think is important for a number of different reasons. And it kind of goes without saying in many use cases, but as we work with higher dimensional data or image data, the challenges of verifying consistent output, even when there are, say, like inconsequential variations in the background that might have an outsized impact on the algorithm performance, one would want to verify that they've done some testing to show that the performance is stable over some nominal range, and that they've done their due diligence in showing that it is insensitive to inconsequential variations of confounding factors. Confidence awareness is another topic that's getting a lot of scrutiny, and rightly so. It is something that is a critical piece, particularly challenging with things like deep learning models, which tend to be overconfident. So, of course, here we recommend that not only should one be able to provide some degree of confidence or uncertainty, but also make sure that those are calibrated with the actual performance observed on the evaluation data. Adversarial resilience is another topic of quite a bit of research and debate. And one of the things that we notice is that while there are some well-developed use cases for adversarial attacks and when they might occur, in working with JPL, we noticed that the concept of adversarial resilience can be broadened not just to a particular nefarious actor, but maybe any kind of process which affects the integrity of your data could be thought of as an adversary, such as like radiation or something else that might impact the quality of your sensor and its collection capability once it's deployed. And one would want to have some understanding of how those effects might impact the data quality and how that might impact the eventual performance of the algorithm. Interpretability and fairness are two more subjective concepts, but they are extremely important in the development of trustworthy AI systems. For interpretability, we mean something that's a little bit different than explainability. Often when we're talking about explainability, we're talking about providing attributions to predictions, which sometimes may or may not be helpful in actually giving stakeholders confidence that the algorithm is performing as expected. So getting user feedback frequently and getting stakeholders' opinion about what features they would like to have visibility on is just as crucial in this phase of development of the algorithm. Fairness, again, often spoken with reference to demographic concerns. And while those are important, even if one is doing something that has potentially no impact on people, fairness also applies to things like the relative representation of different subgroups or populations in your data. So even if not all subgroups are equally represented, having some understanding of the different performances across subgroups and how one might mitigate the relative performance changes if encountering poorly represented data when deployed. And the last attribute in thread 2 is familiarity, which refers to the comfort with which a user successfully operates the system. If users are not happy or willing to use your AI algorithm, then one would question whether or not the project was a success or failure. So having their engagement early from the user community to get their input on what they would like to see from a user interface perspective, having them have some sense of control maybe over the algorithm development and the pieces that went into it would be crucial here as well. All right, now as we move to the final stage of the machine learning lifecycle, pre-deployment gets a lot of emphasis in MLOps, and rightly so. Here we want to be able to think about the target environment, what hardware limitations will be present, and prepare for packaging the model and whatever software environment might be relevant for deployment. And finally, monitoring and control are two critical pieces where, again, we want to have the ability for anyone to query the system performance and have awareness over models and whether or not they are meeting the performance or key performance indicators that have been specified at the very early stages of the model. And control over the algorithm, whether that mean intervention or being able to fall back to other systems if something were to occur when deployed, all very critical here as well. So just to wrap up, we feel like even though many organizations are still developing their AI strategy, and how they plan to do things like trustworthy development. This is also an opportunity to build culture and the infrastructure to support trustworthy development. And we hope that with the growing body of literature from the DoD and other organizations will help them manage this growth opportunity and allow them to implement things like MLOps practices and trustworthy development and reduce the risks of AI deployment. So, thank you. Sure.
My question is about organizations that are making proprietary AI systems. Like, how can they go about making the systems as transparent, I apologize, to their users without violating the proprietary thing? Do you have any suggestions for that?
That's a good question. I think, I think that will probably come down to specific regulations that might occur. In particular, like there's already been developments along that way within like the financial sector, for example, where any algorithm that's been deployed that has a significant impact on someone's financial well-being, there are requirements in place about how one what types of algorithms are developed and how they're audited. And hopefully those would provide enough incentive for proprietary companies to consider things like transparency of the algorithms. But that is a tough question. There has to be enough incentive for them to put in the effort. And users might not have a great understanding of how the AI algorithm works. And that might have a detrimental impact on user trust, but maybe not enough for them to take it seriously.
Thank you. Anybody else? All right. Oh, yeah, please, come on in.
Hi, Ross Keener from Affotech. Have you guys given any thought to or looked into accounting for the fragility of that trust once it's built with the operators?
Yeah, another great question. So I think we tried to address that in the discussion I had here today, in that having users engaged as early as possible might be the best way to address that, and have them know that it's not going to be perfect. And we're going to do our best due diligence to put in all of the processes we can think of to demonstrate that this thing is going to work as expected. But having them aware of what the performance limitations are, managing their expectations, might be the most important. Yeah.
I think it's sort of probably related to the idea of calibrated trust. Where to use it, where it's most effective, where to avoid using it.
Yeah, exactly. And something I glossed over quickly is something like, during the pre-deployment and deployment phases, you can do things like shadow mode testing, where it is available and working in parallel with users, and they can see what the AI algorithm is doing before it's allowed to have more direct influence on their workflow or decision making. And that might help as well.
There's one question up there.
Okay. You mentioned transitioning machine learning to deployment. However, in the last session, it was brought up that there is limited data to validate models, i.e. there are certain threats we can't test against. Similarly, there is limited data to train machine learning. In such situations where there may be gaps in training sets, how should organizations deploy such machine learning and still trust machine learning to work across the entire operational envelope?
Yeah, well, another great question. So I So I think in this case, again, that pre-deployment stage is critical. You know, some of the best practices that have been recommended from MLOps, for example, would be A/B testing and shadow mode testing, like I just mentioned, where, if possible, a scale deployment where you can allow it to interact with a more complex environment, monitor its performance and impact, and minimize the blast radius, so to speak, if possible, and have the ability to switch back to the other algorithm when things are clearly going off the rails is probably, again, the best bet. Not going to be appropriate for all use cases, though. And some concerted effort for pre-deployment data collection as close as possible to the deployed environment is probably your only opportunity to catch those kinds of issues at that stage.